Hello learners, welcome to this course on practical machine learning using Google Colab. So in this video tutorial, let us continue with our discussion on the fundamentals of computer vision. So here I am going to discuss about kernel and convolution operation. So kernel or a convolution matrix is nothing but a tiny matrix, a small matrix, which can be used for different operations like blurring an image, sharpening an image, to find the edges of the objects in an image, to extract the features like shape feature, texture feature, color features, and other image processing applications. So we can make use of this matrix. And it is also one of the very important concept in your machine learning algorithm. So if I want to do any machine learning task, we can extract the features, and that features can be used for teaching a machine. Then the test images can be extracted the features, and these features can be compared with the already saved features. So thereby we can make a prediction on the input. So this kernel or the convolution matrix plays a very vital role in any image processing or in machine learning tasks. So we have different types of kernels available. Like here I have shown some 3 examples of 3x3 mean kernel, which is nothing but an average kernel. So where it contains all the entries as 1. So here when I take this neighborhood is a 3x3 neighborhood. So usually this kernel will be of odd size. So I can take a 1x1 kernel or 3x3, 5x5, 7x7, 9x9 or 11x11. So it should be an odd value. Why? Because we should have a center pixel value. So I should have a center pixel to compute. So when I place this neighborhood on an image, then I do some operation, then that result will be used for replacing the center pixel value. So then here I have shown a little bit larger sized 5x5 Gaussian kernel. So where you can see at the center I have a large value. Then along north, south, west and east I have the second largest value. Then along the northwest, southwest, northeast, southeast I have little bit lower value. So as I go towards the outer side of my kernel, you can see the value gets decreased. So you can see typically a Gaussian shape in this matrix. So at the center point I have a maximum value. On the left side the value gets reducing. Same way on the right side also value gets reducing. So which indicates a kernel is in the form of a Gaussian distribution. So that is why it is called as a Gaussian kernel. And this kernel also is used in the blurring operation. And here on the third kernel, I have shown you a 3x3 Sobel kernel, which is mainly used for your edge detection purpose. So now, like this, we have different types of kernels are available, and each kernel will has its own functionality or feature which it will get extracted from the image. So let us see the convolution operation. So convolution operation is nothing but something like a dot product. So here let me show you how this convolution operation is being performed. So by applying the kernel matrix on an image, we will get some interesting effects like blurring, sharpening, edge detection, feature extraction, etc. How this convolution operation is being performed. So here I have defined a kernel matrix, 3x3 kernel matrix with certain values. First thing what we have to do is we have to take an image. So let us consider this left hand side is your image and its matrix values. So we try to put this kernel matrix on top of your image. So for example, here if you see, now I take this position. In this position, I am going to place this kernel matrix. Then what we do the dot product. So dot product in the sense element-wise multiplication, then add all those values. So here if you see, 0 image I have in this position 0, and in kernel matrix I have 0. So 0 into 0 plus 0 into minus 1 plus 0 into 0 plus 0 into minus 1 plus 105 into 5 plus 102 into minus 1 plus 0 into 0 plus 103 into minus 1 and plus 99 into 0. So that is what we have shown here. So when I do this computation, you will get a single value. So here I get a value of 320. So this 320 is used for replacing the center pixel value. So instead of this 105, we use 320. Next, after doing this computation for one pixel using the neighborhood, now we move this kernel matrix towards right by one position. So when I do that, what happens? You can see now the kernel matrix has been moved towards right by one position. So now again I do the same dot product here. So 0 into 0 plus 0 into minus 1 plus 0 into 0 plus 105 into minus 1 plus 102 into 5 plus 100 into minus 1 plus 103 into 0 plus 99 into minus 1 plus 103 into 0. Then I get another value 206. So this 206 will be used for replacing the 102. So like that we are going to do this operation from left to right, and then also we move this matrix from top to bottom. So thereby we compute all these values. So this matrix which we get after this convolution process, we can call it as a feature map or some special function output. Something like a blurred image or a sharpened image or edge detected image, or we can also say it as a feature maps. So this process is called as a convolution process. So usually when we don't have this 0, so this 0 is intentionally added on an image. So actually our image contains this values alone. From 105, 102, it goes on like this. So but I can't place this kernel matrix for the computation of this top row, column, left column, same way bottom row and right column. So we will not be able to compute the values for this top row, left, bottom as well as right columns. So in order for us to compute these values for the top row, bottom row, left and right, we try to put zeros to the matrix. We add zeros to the image matrix. So 0, the value of 0 means we are essentially creating a black border. We are essentially creating a black border on an image. So by doing so, I can apply this kernel matrix on the image and I can compute a value for this top row elements, left elements, bottom row elements and right elements. So this technique is called as a zero padding technique. So which is very useful if I want to have consider all the elements in an image. If I am not going to do this zero padding, then what will happen? My computed matrix, my convoluted matrix will be smaller when compared to that of your input image size. So thereby we are losing some information from the image. So in order to retain all the information, or if I want to use all the information, then it is better to go with a zero padding scheme. So the zero padding scheme will help to use all the elements in an image for our final computation. So this operation is very, very vital in any machine learning or in image processing tasks. So here one more thing which we need to know is, here when I move this kernel matrix on the image towards right as well as towards bottom, here I take one step. So this movement is called as a stride value. So stride value of 1. We can also move this kernel matrix towards right by 2 positions or 3 positions or 4 positions. Then the stride value changes. So stride value can be 2, 3, 4. So there we will be losing some information. And another thing with this convolution operation is, if I use a 3 by 3 kernel, then I'm trying to get the information for the center pixel from a smaller neighborhood. Instead of 3 by 3 kernel, I can use a 5 by 5 kernel or 7 by 7 kernel or 9 by 9 kernel. A larger kernel can be used. In that case, the center pixel value is computed based upon a larger neighborhood. So it will be something like a larger objects can be covered easily, whereas a smaller objects by using a larger kernel will not be able to yield very good results. So we should take into consideration that what type of image we are using. So if our image has lot of details, lot of minor components, lot of components are available in the image, in that case a smaller kernel will be very efficient. Whereas if I have only one big object, so or one or two big objects in my image, then in that case I can go with larger kernels. So larger kernel means the number of tracing along the right direction as well as from top to bottom will be less. But the pixel values which we determine, the feature values or the computed values which we determine, it is determined based upon a larger neighborhood. So this forms the basics for your image processing tasks like smoothing, blurring, sharpening, edge detection and other feature extraction algorithms. Thanks for watching. Please subscribe for more technical learning. Thank you.